Hey math fans! Welcome to Math Olympiad Academy, your trusted space for advanced problem solving and logical reasoning. We sincerely thank our subscribers and all viewers for your continued support. In Lesson 34, we present a structured lesson that explains step by step how to find the sum of a sequence defined by its general term, and then conclude its limit as n tends to infinity. The objective of this lesson is to guide students to find finite sums, exactly using the telescoping series method, reinforcing algebraic factoring techniques, and demonstrating how exact summation leads directly to limit evaluation. In this problem, let the sequence S sub n equal the sum from k equals 1 to n of the quantity k squared minus 1/2 over k to the 4th power plus 1/4. The questions are as follows. The first question in this quiz is, which expression equals S sub n? Choose from options 1, 2, 3, or 4. The second question is, find the limit of the sequence S sub n as n tends to positive infinity. Now, let us begin the solution of this sequence, denoted S sub n, which equals the sum from k equals 1 to n of the quantity k squared minus 1/2 over k to the 4th power plus 1/4. Many students ask me, where should we start this problem? Well, the general term of this finite sum is given by a sub k equals k squared minus 1/2 over k to the 4th power plus 1/4. To rewrite this term clearly, let us first multiply the numerator and denominator by 4. This allows us to rewrite the general term a sub k as 4k squared minus 2 over 4k to the 4th power plus 1. Now, let us factor the denominator, namely the quantity 4k to the 4th power plus 1. By adding and subtracting 4k squared in the denominator, we obtain the quantity 2k squared plus 1 squared minus 4k squared. Then, using the difference of squares, we get 4k to the 4th power plus 1 equals the product of the quantity 2k squared minus 2k plus 1 times the quantity 2k squared plus 2k plus 1. This is known as Sophie Germain's identity. So the general term, 4k squared minus 2 over 4k to the 4th power plus 1 becomes 4k squared minus 2 over the quantity 2k squared minus 2k plus 1 times the quantity 2k squared plus 2k plus 1. Now, since the denominator of the general term is expressed as the product of two quadratic expressions, the partial fraction decomposition of this general term allows us to rewrite it as the quantity a times k plus b over 2k squared minus 2k plus 1 plus the quantity c times k plus d over 2k squared plus 2k plus 1. To find the real constants a, b, c, and d, multiply both sides by the denominator. This leads to the following equation. 4k squared minus 2 equals the quantity a times k plus b times the quantity 2k squared plus 2k plus 1 plus the quantity c times k plus d times the quantity 2k squared minus 2k plus 1. Matching coefficients leads to 4 relations. The first one shows that the constant c equals negative a. The third relation gives b equals d. And by replacing b equals d in the fourth relation, we obtain b equals d equals negative 1. To determine a and c, replacing the values of b and d in the second relation gives a equals 2 and c equals negative 2. So the decomposition gives a sub k equals the quantity 2k minus 1 over 2k squared minus 2k plus 1 minus the quantity 2k plus 1 over 2k squared plus 2k plus 1. Now, notice that 2k squared plus 2k plus 1 equals 2 times the quantity k plus 1 squared minus 2 times the quantity k plus 1 plus 1. Replacing this expression in the previous general term formula, we obtain the equivalent form written as A sub k equals the quantity 2k minus 1 over 2k squared minus 2k plus 1 minus the quantity 2 times k plus 1 minus 1 over 2 times the quantity k plus 1 squared minus 2 times the quantity k plus 1 plus 1. Hence, the general term can be expressed as A sub k equals b sub k minus b sub k plus 1, where b sub k equals the quantity 2k minus 1 over 2k squared minus 2k plus 1, and b sub k plus 1 equals the quantity 2k plus 1 minus 1 over 2 times the quantity k plus 1 squared minus 2 times the quantity k plus 1 plus 1. This expression is helpful for telescoping the sum. Now, let us evaluate the values of each term, b sub k minus b sub k plus 1, namely k equals 1 gives 1 over 1 minus 3 over 5. K equals 2 yields 3 over 5 minus 5 over 13. K equals 3 leads 5 over 13 minus 7 over 25. And so on and so forth, till k equals n, which gives the quantity 2n minus 1 over 2n squared minus 2n plus 1 minus the quantity 2 times the quantity n plus 1 minus 1 over 2 times the quantity n plus 1 squared minus 2 times the quantity n plus 1 plus 1. Now, by summing term by term, all terms cancel, and only the first and last terms remain. Namely, the sum s sub n becomes 1 minus the quantity 2 times the quantity n plus 1 minus 1 over 2 times the quantity n plus 1 squared minus 2 times the quantity n plus 1 plus 1, which equals 1 minus the quantity 2n plus 1 over 2n squared plus 2n plus 1. And after writing all under the same denominator, some terms in the numerator, like positive 2n and negative 2n, and positive 1 and negative 1, cancel out. And we obtain 2n squared over the quantity 2n squared plus 2n plus 1. Thus, the correct answer is s sub n equals 2n squared over the quantity 2n squared plus 2n plus 1. Now, let us move to the limit of the sum s sub n, as n tends to positive infinity. This limit equals the limit as n tends to positive infinity of the quantity 2n squared over the quantity 2n squared plus 2n plus 1. After factoring out 2n squared from the numerator and the denominator, and simplifying by canceling 2n squared, and since 1 over n and also 1 over n squared approach 0 as n tends to positive infinity, we conclude that the limit of s sub n as n tends to positive infinity equals 1. Hence, the limit of s sub n as n tends to positive infinity equals the limit as n tends to positive infinity of the sum from k equals 1 to n of the quantity k squared minus 1/2 over k to the 4th power plus 1/4, which equals 1. Now it is time for homework to practice and apply what we have acquired and assimilated through this lesson. For this objective, try to evaluate the sum of this sequence, denoted s sub n, which equals the sum from k equals 1 to n of the quantity 2, k, over k to the fourth power plus k squared plus 1. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!